A very good morning, one and all. Respected dignitaries, invited guests, teachers, research scholars, and hope you all are having a productive as well as healthy time. On behalf of Department of CSA, P.G. Bhubaneswar, I, Subhashri, with my friend Arpita, heartily welcome you all to the second day of OTTA's Online FTP 2021. For this year, we know the topic is Artificial Intelligence and Machine Learning. You will be thrilled to know that today we are going to have a discussion about cybersecurity, energy, intelligence trade-offs in IoT, and geospatial intelligence in the first half of our session. Along with that, after lunch break, we will continue the technical session on case studies of artificial intelligence and machine learning. So let's start today's program without any delay and get ready to encounter an ocean of knowledge.
Before starting the session, I'll request all of the participants to please mute yourself, and if anybody is having any queries, feel free to drop the queries in the chat box. Moving towards our technical session, today we are going to talk about security. Yes, viewers. We must know the facts and reality of internet as well as the security standards. Let me have the honor to invite the first speaker of the day, our honorable guest, Professor Saraju Mohanty sir from North Texas University, USA, to brief us about the topic on cybersecurity, energy, and intelligence trade-offs in IoT. He has worked as technical consultant in Shenmalan LLP Dallas previously. He has an experience of being a lecturer in OUT Bhubaneswar. He holds a PhD in Energy and Transient Power Minimization from University of South Florida, USA. He has also done ME in Artificial Intelligence program from Indian Institute of Science, Bengaluru. We are really dignified to have such a great personality with us today. Now, let's welcome him and request him to pour some thoughtful words on today's topic. Over to you, sir. You are not audible.
Hello, everybody. Thank you for the opportunity to share my thoughts on this hot topic on cybersecurity AI and all this together. And I really appreciate all the kind introduction that we had. So this is a 2-hour discussion, as I understand from the schedule, and we have a lot of slides. So feel free to interrupt me when you have any questions or anything, so that we'll have a more interactive learning than just covering the slides. The slides are in public domain in my website. You can download, and you can have it in your local computer, so that it will be easy to follow, even if you have a bandwidth problem. So the topic, as it suggests, is cybersecurity, energy, and intelligence trade-offs in IoT. All of us are aware IoT. IoT is not necessarily internet. It is internet connecting to something other than the computing device. So that is how the IoT came. And cybersecurity is a very important thing because everything is connected to the internet, and there are bad actors who want to create chaotic situations so that people will have inconvenience and so on. Cyber attacks is what you can say regular phenomena. And energy consumption happens in the devices, in communication, in the computing tools that we use in day-to-day basis. And then third word I have here is artificial intelligence. So we are trying to make things intelligent so that devices and systems will work in a kind of automated fashion. So the topic here is kind of looking at how the trade-offs are there, instead of seeing those three are three independent things. So the cybersecurity, energy, and AI. Instead of independent, they are very related, and there are, in fact, kind of what I call as a conflicting objectives. We want, for example, things to be secure. When we make things secure, it has energy requirement. Then we want things to be connected, and when we connect them, it has its own set of problems. Cybersecurity coming to picture as a result of that. we want to have AI, artificial intelligence, and day-to-day life, whether it is a smart device or other things. A lot of things are AI driven, and they are also connected. As a result, they also suffer from cybersecurity problems. So all these three, we are trying to put them together in a thought, and then we are looking at IoT, not just internet, beyond internet thing. So that's the kind of big picture I'm going to discuss. And all these are driven by always demand. Okay, so we are essentially going more towards smart cities environment, and as a result, we have a lot of problems that we are facing. And these problems, like what I call them as sustainable challenges, has last 10 years driven the new idea of making smart cities. So smart cities are essentially cities which existed before. Of course, we are not necessarily making what we can call as a greenfield smart city. There are a few. For example, in India itself, Nairapur in Chhattisgarh state is an example of greenfield smart city. Similar examples are there, but most of the smart cities are cities existed, and we are using IoT, cyber physical system, those frameworks to solve the sustainable challenges. That is what's going on. And I wrote an article in July 2016, which is considered as the most widely read article on smart cities. I recommend all of you to go through that. And the objective there is to improve the quality of life predominantly. And prediction has been in next 30 years, 70% of population will be normal in cities. Okay, and kind of motivated by the success of smart cities, other initiatives like smart village, smart state, smart countries are being what you can say conceptualized. And I'm a great believer of smart villages, and particularly in the context of India, where the first slide itself I mentioned that is India has a lot of villages, and if we make villages smart, probably what I say, probably smart city problem will be solved automatically because people won't migrate. So anyway, so that's why these are interrelated things. And as I said, this is not a necessarily a keynote or whatever. This is interactive discussion. Please feel free to interrupt, and the chat window put to your questions so that we can have interactive discussion, even though we are doing a webinar and so on. So smart city initiative started a long time ago. Actually, people say like first when first city started, it's very old. Smart even village started, it's a very old thing. And even the initial thought of what is called digital city, the predecessor of smart city, 1994 is Amsterdam, is considered the first one, and then followed by there are a lot of things going on, like Dubai, some things made smart, some components, and then right now in India itself, a lot of initiatives are going on, and IEEE is trying to help from 2015 with a smart city initiative to give the technical guidance. In fact, even I hear in the smart village concept of IEEE is also being explored in India, in some places of Himachal Pradesh and so on. So anyways, that's the history, and you can read more later. So when I compare, okay, smart cities versus smart village, they are like for a electronics person, okay, or AI person, they may be same because it's a physical entity with IoT sensors, this and that are connected. But when it is coming to the practical aspects of it, smart city, smart village may not be same, may not be the same objective. When smart cities, cities have a lot more money, a lot more operational budget. As a result, there we can put anything we want, like centralized servers, high bandwidth internet, and so on. So we can make things much simpler. And in technology deployment may be relatively easy because a lot of money is there. You can hire very good engineers and so on. So that smart city objective, because a lot of population, lot of operation costs, how to make it sustainable when a lot of populations are staying. That's the challenge there in the smart city. But in smart village, like technology wise may not be that much available. The operational costs, operational budget for a smart village is way less. So how do you make a village sustainable with very limited budget? In fact, sometimes you may not have electricity continuity, you may not have the internet, and how do you make smart? So those are different levels of challenges that we can compare smart city versus smart village. Now, when we see in general, and there's a little bit technicality here added along with the concept that we just discussed. It is instrumentation, interconnection, intelligence are three I's, what I call. These are valid even for the smart village. These some eyes and ears, we are hearing, we are listening to something or other. And those sensors and actuator are instrumentals, microcontroller, those, and they're all these devices which when internet started, they are supposed to be only connecting computers, though exactly telephone network connects to only telephones, like that. But first time, maybe in the mid 90s, something other than the computer was connected to internet. That was a toaster, okay, a bread toaster, and then that originated the idea of Internet of Things. That means something other than computer connected to the internet. So interconnection is very important. And then we make certain decision. Let's say we sense, then we decide, okay, let's say for example, you want to automate the street light system. Okay, when it's dark, let the street light be on. When it is not dark, let the street lights be off. That's very minimal level of automation I'm mentioning. So some level of data collection, and then based on the data, some level of actuation happening, and AI or intelligence. That is how this comes to picture. So three I's of smart city are equally valid for smart village. So IoT is what is making these things the technology underneath making these things possible, and it's the things, it's the local area network, then the cloud services, and so on, and then different applications built around it. So like these what you can say Internet of Things, when deployed in the context of physical things, for example, you could deploy this in a home, home becomes smart home, then we can consider that whole thing as cyber physical system. And similarly, when we use IoT in let us say for example transportation, that becomes a transportation cyber physical systems. Like that, IoT and cyber physical system are connected with each other. Okay, these are what you can say same or similar things in a different granularity. So IoT, CPS, smart city or smart village, those are the three hierarchical view. Top down we can comprehend, or we can comprehend bottom up. So when cyber physical system we comprehend at the big picture, we can say that in the physical we have IoT in deployed, and we at the result we get the CPS. Now one example, smart healthcare is one I call rather that in a bigger context, healthcare cyber physical system that is not just like a wearable that we see, or a whether wearable in hand or head and so on, which are medical devices. But in addition to that, a full hospital being made a smart hospital. Then, for example, in a current, let's say, healthcare situation, all the healthcare record, whether it's X-ray or CT scan and all these things, we have electronic, and it is shared in a server in privacy assured fashion, and so on. So the overall, we call in general, we can say that data is electronic health record, EHR. All these together makes what is called healthcare cyber physical system. So smart healthcare is one of the component. And then, as I was just saying, that is, we can comprehend that as a healthcare civil cyber physical system, not just saying smart healthcare, which is more broad term. Healthcare cyber is more technical term, and this encompasses everything, that is sensor to connectivity and so on. And this is a big market for the healthcare. We have roughly a $350 billion market, more or less, and it will be much more because of the pandemic situation that we are seeing. Healthcare market may be much more. Before, when I was getting this data, maybe around 4 years ago, that time energy was the highest in terms of the market value, followed by transportation, followed by healthcare. But now I comprehend it is energy, followed by healthcare, followed by other things. Transportation can maybe potentially even go down in terms of the market value, because travel has reduced that rather. So anyway, so all these will have different cybersecurity challenges in terms of device data, in terms of privacy of data, and so on. So smart agriculture, another thing which is very important, and in fact I was telling few people, like if you what you can pay attention to India's Prime Minister's 15th August 2020 address, like 1 year ago roughly, he was mentioning about healthcare followed by agriculture, those two major things he was addressing. So smart agriculture, I coined the term called Internet of Agro Things. Okay, in the medical I coined the term Internet of Medical Things, IoMT, and this slide you saw. Similarly, Internet of Agro Things, IoT is another. So these are different examples, specific examples of IoT. Okay, and based on their requirements for the sensors, for the connectivity, and so on, they are not the same, and their deployment in the physical, different physical applications, they are different. So this is the IoT deployed to agriculture becomes smart agriculture. So now this agriculture, again similarly, if we see the data used, the controller, the sensors, and so on, then this is deployed in the field. All these things we combine, then this is agriculture cyber physical system. Okay, and followed by another thing now we have is this is a big rather. I consider energy still as the most important thing. Okay, when I was saying energy, cyber physical system, then healthcare, then transportation, all these things, agriculture, all these have different market segments, and which one is more important than what? Okay, it's a questionable, debatable rather, but energy is much more important no matter what, because even hospitals run with the electric supply. Okay, without electricity we really cannot manage even for some minutes. So that is why energy comes most, and it has a lot more market segments, and as because not just electric vehicle, that's rather way less, but like electric supplies to home, to industries, and so on. So IoT here also plays a major role, and in general we can call this as energy cyber physical system. And then at different details, so smart grid, smart transmission, smart distribution, smart generation, smart storage, all these can come to picture. And where the user is actually involved is at the consumption level. Energy is such a unique situation where a user is consuming, and then the consumption is determining the generation, and some we can store as well, battery. So that's why these are like all these are different sub-disciplines of energy, smart energy you can call, where smart generation, smart grid, smart storage, all these things can work, and IoT play important role in all this consumption as well. Then if we see the transportation CPS, here again IoT plays a lot of roles. So there is a traffic management to toll collection, all these automated we can do. And again here data and device security, location privacy, all these are equally important. This is a reasonable big market, and energy I was mentioning is a very big market. Agriculture is very important, but the market value is a little bit small. Okay, and healthcare I was saying is a huge market value. So anyway, so this is how the different what you can say IoT, then cyber physical system, and industrial IoT is another similar thing, but this is not necessarily for the individual customers, consumers. Okay, this is like more like, as you can imagine, bulk industry. The IoT deployed in industry to automate let's say power sector, or to automate a car manufacturing plant, and so on. So this is industrial IoT, different level of granularity, different level of sensor, actuator, and so on, connectivity, and so on. So IIoT is this. Then what are the challenges? Like we face a lot of challenges. Okay, starting from a lot of scaling requirement, design operation cost requirement, creating data, and the security, as we are going to discuss, is very important, and so on, a lot of other things. And scalability, with the number of IoT devices increasing, that will drive much more problems in terms of power requirement, connectivity requirement, and so on. And security, like all of are aware of these simple situations where credit card is stolen, or something of that sort, where data or something is stolen. That I consider as less valuable, or less what you can say rather severe compared to what is this slide number 22 you are saying. So here, this is the cybersecurity challenge system. Okay, these are much more serious, can create a lot of havoc actually. For example, power grid being hacked. In fact, this year itself in US, the pipeline, one pipeline was hacked in the east coast of US. As a result, the gas pipeline, and as a result, people were having trouble in getting gas, that means petrol, okay, diesel, all those things. So those are serious cyber attack as compared to stealing a credit card or so. So power grid here is an example, and similarly, imagine your car is connected and your car is hijacked by somebody electronically through internet, and he or she is driving. Those are much more serious problems. And study in the smart healthcare, security and privacy is very important. And like here, like a healthcare cyber physical system point of view, the data, confidential data privacy, and then the connectivity, the device security, all these things can be problem in the healthcare domain. And this slide is a very interesting slide, that is IoT security real and scary. Why it is, some examples I have borrowed from newspapers, Washington Post, CNN, and so on. So those newspapers reported that how somebody's pacemaker is connected to internet, and then that pacemaker is hacked. That is a very scary situation. That means you have a device in your body which is hacked by somebody. Similarly, wearable like insulin pump now. For example, somebody is seriously diabetic, and there are systems being developed which will inject insulin automatically, doses level in automatically, and all those can be hacked, and these are scary. So this is in the current situation, in addition to the healthcare cyber physical system and security issues. So this is one slide that I put, that how agriculture and healthcare are related, and the supply chain, whether we are taking the pharmaceutical or the vaccine supply that we see current situation, or medicine supply or food chain, they are parallel, basically supply chains which have to be made robust, made reliable, which may be affected by cybersecurity, may be affected by many other things that we can think of. And in the context of smart cars, so here this slide is an really overview of how things can be wrong in the healthcare sector. This is a very interesting slide that tells how things can be wrong in a transportation, in addition to creating problem like let's say traffic management and so on. But this is underneath detail that I have written. For example, imagine you made everything secure, but one can hack the sensors or mislead the sensors and actuator of a car. So as a result, like a lot of things can go wrong. So this is basically a very scary situation for the driver. That means autonomous cars, not necessarily human is driving, car is driving itself, but car instead of driving by the authentic driver is essentially controlled by somebody else or a hacker. That is a scary situation. And in the context of grid, okay, a lot of things can go wrong, and as a result of different electronics, different connectivity being there, generation, transmission, distribution, and so on, are various different problems. Now, when we see an embedded system in general, slide number I have here PDF 28. So in general, an embedded system has different components, DSP, then embedded processor, memory, and so on. And all these can be attacked in many different ways. Memory can be just like they're stolen. Okay. Then like somebody can sell you fake hardware. Okay, and firmware can be attacked in many different ways. So this embedded system, and it can be part of anything. This is very generic. It can be part of a what is that? Can be part of a whether it's a power system or it is a transportation system, or it is a healthcare system. In any way, you can have an embedded system somewhere sitting with the memory, with the bad hardware, and with some small or big firmware and so on. And RFID is a device that we are seeing that is being used when we are making things autonomous, okay, for access control, for even for parking management, and even for payment purposes. We use RFID. RFID can be hacked in a variety of ways, from the physical threat to system threat in variety of ways, and as a result, they need to be made secure. So, like NFC is another device again heavily used, and these devices like again can have problems, and particularly eavesdropping, relay attack, and so on are serious vulnerability situations for the NFC. And like, because this is again used for autonomous purposes, for whether it is a transit system or security system and so on, it needs to be taken care of. Now, this is detailed, that is all the embedded system I was mentioning, okay, that we see has some sort of firmware, whether it's not just a computer or a simple TV or so on. Everywhere there is some firmware, okay, that is more or less like they are in almost all systems, and they can be a bad firmware can be a problem, and firmware indirectly can be a security threat. Here is the illustration of how a memory, this is a main memory, let us say, can be attacked by various ways, like whether it is a simple spoofing attack or splicing, replay attack. All these are possible, and even a cold boot attack, where somebody can take the memory and quickly cool it in, let's say, liquid nitrogen and so on, and as a result, data can be stored, and then it can be later read. So variety of ways memory, and once memory is stolen, gone, data is gone. Anyway, and this is another scary situation, Trojan. Trojan I have explained here in very simplistic, which is can be a very simple hardware modification or software modification, and as a result, this hardware software modification, one can get wrong output from input. Okay, instead of like somebody expected, oh, I'm getting a 1010 giving input, output I'm getting similar binary, but the binary you're getting is a bad binary than the binary you expected. So that is a simple example, and this Trojan can really cause serious problem in critical applications. Let us say military application, let us say applications in power grid and so on, where you think you have a great hardware, but hardware has Trojan, which adversary can take control, and as a result can take control over the whole system. So that is why this is a very difficult attack to fix and have a robust system. Side channel, this is another, like last 10-20 years, I see a lot of people have worked on it, because this is like is attack where encryption, even though how robust you make an algorithm with thousands of keys, okay, this encryption can be defeated by analyzing the hardware behavior instead of defeating the software, defeating the encryption algorithm. So this is a serious cybersecurity attack as well. So when we see like all the attacks and so on, I read the details, and I say, okay, not everything is essentially security problem. In general, cybersecurity, privacy, intellectual property rights are three different things, not same thing. But people combine those all three in a bigger umbrella of cybersecurity. They are different, distinct problems. Okay, privacy is, let's say, your healthcare record is compromised. That's a privacy problem, not necessarily a security problem. Then let's say your hardware is cloned, or your let's say movie is cloned. That's a IP right problem. And security wise, when something is really stolen from the memory, or some Trojan, through Trojan some system is taken control over, those are the security problems. Anyway, and privacy, even though I was mentioning, like cybersecurity is an important problem, and a lot of people care for privacy, personal data, because data is value. Data is what people call as a new oil. Okay, like oil is petroleum. That means oil is expensive. Data is now quite expensive, and so privacy, that is why is an important challenge. And not just data privacy, location privacy, system privacy, all these are also becoming important challenges. For example, you probably want to hide where you are, okay, when you are driving autonomous car, and then your information known in the internet where you are. And when you have enabled the GPS, people know where you are. So like that, all the location privacy. Similarly, system privacy, that means let's say, for example, in a car, I own a car, I don't want anybody to know what are my electronics, what are my sensors, and so on in the car, because then they can exploit it, and then they can break the security and other features of the car. As a result, the privacy can eventually lead to much more serious problems. So we want to have privacy, not just here mentioned data, which everybody is aware, location privacy, and the system privacy, that means device, what are the configuration, what are the specs. Continue.
Yes, sir, please.
Okay, so now we have now some idea of security, privacy, intellectual property rights, and so on. And a very important point I mentioned here, privacy, like even though less severe than security, as I was mentioning, but this system privacy problem can lead to eventually security problems. And if we combine all these the thoughts so that we have like data, Internet of Things, and so on, this is a slide that gives us a very good perspective that how things are. Okay, deep learning comes from data. Okay, and then Internet of Things are collecting data and then making decisions on our behalf, and then biometric and so on are important. And at the top of it is privacy and security. So then the question will come, okay, where we want to have security solution, where we want to have AI solutions, that's why whether close to the user or away from the user, and so on, all these details we'll have. So we are making things intelligent by the help of what you can say these data that we are seeing. Data is being trained, and ML modeling, that's why machine learning modeling is very important. Anyway, so machine learning modeling is an important in general. Why we are doing machine learning modeling? Because we want to make things intelligent, and from the data we make models, so that those models then essentially reflects human intelligence, and then works on our behalf. Okay, so the development of models is very important, and it's very what you can say resource intensive. Okay, high energy requirement, high resource requirement are there, and because we are dealing with a large amount of data, okay, and particularly sensor data. Let's say, for example, you want to have let's say weather data, like or water quality data or air quality data. Okay, those are rather simple, but when we are taking data coming from various sensors on a continuous interval, okay, instead of 1 hour or 3 or half an hour, that kind of interval, continuously we take data, then that will create a lot of data. And it seems in the transportation domain, all the like location wise, the different vehicles data along with the traffic and so on is a lot of data. And a healthcare domain, similarly, let us say when individual persons data we are seeing, okay, we are collecting maybe simple, but when we talk about right now, particularly we know in the pandemic situation, we're talking about the data of the whole let's say city, then the data of the state, and now global data in fact is monitored to keep track of the infection and so on. So those kind of lot of data, and we make then model of those data. We are predicting, okay, what kind of situation is going on and what can happen next month or so. So that's in general modeling. The resources involved, the storage, the computational resource, and as a result, the energy usage, all these are important challenges. Vast sum of data we're talking about. And to develop very good models, data has to be very good quality data, no fake, okay, nothing. And at the same time, class imbalance and other issues. That means it's not like you have data from one location of the city, not across all the locations of the city, of state, and so on. So this kind of different issues may be there. And when we are developing a model, as we just mentioned, model development, that is training, it needs a lot of energy, depending on the amount of data, depending on the how complex models and so on we are developing. And once the model is generated, it needs to run, the execute, it needs to predict from the different data. Once we got the model, that model needs to run and then do the job, and that also needs energy. And so in general, that's the energy requirement to make intelligence a significant problem. Okay, how much energy needed to develop the model and to run the model. And what has been found, models are not always smart. Okay, particular DNN or AI is not necessarily always smart. We are using them to make things smarter, but it can be as simple as some mathematical formula, some model. Okay, and here are some examples how different models have been developed by certain people, and how a penguin represent, how a starfish represents, how electric guitar is represented by certain model when model developed and visualized. And in fact, authors have found that to make model that represents, for example, cheetah, or to model that represents a centipede, for example, here or there, those can be easily developed. The equal, what you can say, model it will work effectively with what is called white noise. And that is, it's not necessarily always like that, but sometimes people are saying like with a noise and so on, they can develop a model. So this is a illustration that suppose we have models which are wrong, okay, or little bit problematic. For example, here is a very nice illustration that is a stop signal is somehow, let's say, a model is wrong and model says, okay, stop signal is a speed limit signal. Okay, stop sign is a speed limit sign, and something like that. A little bit problems in the model can cause serious problems. So robust data, robust modeling, all these things are needed. And model can be in what you can say explicitly by, or intentionally made wrong, okay, by attacking it in various different ways. That is corrupt decision, or at the training time things can be made wrong. And as a result, the AI model, okay, which as we now know needs a lot of energy, okay, and can be bad model, and can have its own security issues. That is, model is wrong. And what you can say, to allow the AI energy requirement is. So now if we see other way around, the energy aspect, okay, energy aspect, if you see, remember what we are discussing, the big picture of what are the challenges of cyber physical system or IoT. Okay, so AI challenge and AI issues we solve, and so on. And then here we are talking about energy requirement for the whole city, for the whole state, for the whole country. Okay, all these are significant, and electronics in all these situations cause a lot of what you can say, consumer electronics is a component of it, but overall electronics consumes a lot of energy, not just air conditioning or heating that this data source. And what is observed actually, the data centers, which are essentially making like when you run a search engine or we are in Facebook or LinkedIn, all these data centers are there, and those consume quite a bit of energy. So when forget intelligence, just energy requirement is there for the servers, and then energy consumption, energy usage that we saw. But when we want to talk about storage of energy, this is also important problem, because they need to have all the servers need to have backup and so on. So now, coming to the consumption of energy, we are talking about intelligence consumption. Okay, that is, we have let's say our smart mobile phone, and in smart mobile phone we have power save mode and other modes are there, and in all those modes, we are trying to deactivate certain apps and so on. Okay, those are the practical scenarios I'm talking about. High energy optimization is a difficult problem, and how different components are helping to optimize the overall battery life and so on. Now, so a lot of people have worked on cybersecurity. Like I can imagine, this is one of the hot topic, and then tons of people around the globe are working. Okay, anywhere you see, cybersecurity research is going on. So this is a big picture. Some authors from Princeton, like this big, they analyzed and they kind of tabulated what are the different cyber attacks possible in IoT, and not everybody can work on all the problems and solve. Okay, and starting from what is going on in the computing nodes, communication nodes, is computing devices, and so on. They all of them have worked, and as a result, there are a lot of solutions, a lot of countermeasures, and then this is an example of one common people, very simplistic point of view, what they think as security. Access control, right? That is to get access to a computer or to get access to a building and so on. But overall, cybersecurity is way beyond this, not just access control by fingerprint or easy signal or face recognition, which we are obviously doing. There are applications everywhere, like whether in my house I have electronics locks, or in the airport we have passport control, which are automated, is example of these applications. But like cybersecurity solutions for even a credit card, this is an example. We did a new generation credit card with biometric integrated in it, and then how we developed the corresponding protocol and so on, so that the credit card is foolproof. And even RFID point of view, a lot of solutions are there to make them secure. This is a very important example. This is our current area of research, essentially. I have two federal funded National Science Foundation, which is the federal funding agency of US, exactly on this area, where we are trying to basically come up with cyber security solutions for the healthcare, healthcare data, healthcare device, and so on. And in this, actually, we cited, we referred this work in 10 years ago when Princeton did. They demonstrated that is how, what is that, insulin pump can be hacked, and then how they can protect it. So that is one of the oldest works that I've seen. And for last maybe last 5-6 years, we have developed a lot of solutions in this area. And that's the current topic. You can go to my website to have a lot of solutions on the blockchain. Blockchain based data, and a lot of people are doing, and we have done, but blockchain based device security, that is the way, for example, blockchain based, this is not a blockchain solution when they started Princeton around 10 years ago. That is this is very simple solution they provided. We are trying to do with the blockchain and so on, device solution, not just data. And when we're talking about security in general, that is autonomous car is a major thing I have mentioned, and particularly when the sensor data and the actuator can be mismatched and the people can take over the car. And as a result of this, people are working how to coordinate the signal that is generated from the sensor and going to the actuator, and that signal essentially is important, and collision avoidance point of view that can be done. And one solution was proposed by some people 5 years ago. This is from Texas A&M. This paper they did is to come up with dynamic watermarking to kind of check the integrity of the sensor signal at the actuator. This is a cybersecurity solution. Data is important. Data can be protected. Very simple. A lot of people are working with encryption based. But this one, which is not main memory, sorry, not the hard drive, okay, rather the main memory protection, so that data is not stolen during the execution. That is a much more important problem. It's not many people are working, but some people are working. It's an embedded system problem than storage hard drive protection. This not many people are working is firmware security. That is definitely encouraged. Firmwares are everywhere, whether it is an electronic device going to a healthcare device or to a power and so on. Okay, everywhere, like firmwares are there. Okay, or it is a electronic control unit going to issue, everywhere firmwares are there. And as a result, firmware security is very important, and because it can completely make hardware dysfunctional. So people can basically override the firmware, take control of the hardware. It's as simple as that. And we knowingly or unknowingly, actually, a lot of people do what is called jailbreak of the smartphone, which is essentially breaking the firmware security. A lot of people do, and then that is not that severe problem. But if you jailbreak the firmware of a, let us say, electric control unit that goes to a car, let's say car brake, it's a very good high-end car, and people, somebody sold you a fake hardware at cheaper price, and then you put that issue in your car, that is a serious problem, and that firmware problem and other things can be really leading to serious security cases. So these are some examples as we saw are security solution in very different contexts. This is generic. This is only access control point of view, credit card, RFID, then medical device, this is medical data, this is smart transportation, and this is for the main memory and the firmware. All these are different, and many other solutions we can think of, and we have worked on many of those. Energy solutions are also important. Energy consumption at different points of the internet are different. Cloud is different. Sensor is different. Sensors are battery driven. Okay, may not have much more power. Cloud, on the other hand, can get power from the wall, that means from the grid, and a lot more power, and so on. So, all these things are there, and then this consumption challenge, depending on where we are challenge are different. This is the sensor. Okay, it is less power and energy constant rather operations. This is a lot more power of the cloud, but energy bills are quite high. Data centers do consume a lot of power as well. So when we think of how to solve this power problem, okay, these are not simple, and these are depending on the groundwork, depending on what you can say, details can be different. So system application, energy consumed in the communication, energy efficient software, energy efficient hardware, smart battery, all these are variety of ways that we can solve the power problem of different in the overall when we see the electronic system point of view, system level solution, application level solution, and so on. All this can be done. And if we think one example of system level solution, let's say we are solving the energy requirement of our home. Let's say, for example, when we are not at home, let the air conditioning automatically shut down itself, which is what we do in our home. That is, when we are not at home, let us take care of itself. And similarly, all the electricity, let's say all the bulbs or so on. And the left side, like is an example how smartphone is managing its apps and so on, so that overall battery life is better. So that's the example of smart energy consumption. And we can similarly, when we come to the IoT sensor nodes and so on, we can have like a different sensor design, the routing mechanism, and so on to do the low power, what you can say, overall IoT. Now, when we as an electronic engineer will think about how to do energy reduction of the system, we can attack that problem starting from layout level, transistor level, logic level, RTL, and system level. Okay, overall, and different people, let's say here at the system level, computer science people work, architecture. I was doing that level when I was doing PhD around 20 years ago. And this behavioral RTL, and many of my students, like last 15 years, have worked at layout. Now, of course, I'm doing mostly at the system level, APG, and so on based solutions. So energy reduction and consumer electronics hardware in general can be done that the design phase, post design phase. That's why pre-silicon, post-silicon, those methods are there. A lot of things we have done, and a lot of different. In fact, my book, which is a significant 800-page textbook, discusses a lot of pre-silicon, post-silicon methods for energy reduction. If those who are interested in the electronics communication department, electrical engineering departments, they can definitely have this. And one idea that I'm seeing that this is TechSec's instrument developed, Battleless IoT. So I was thinking, okay, what is Battleless IoT? So essentially, that is IoT that is doing energy harvesting. Okay, they coined nicely Battleless IoT, and they may be using supercapacitors. Okay, and so on. Okay, and that idea is interesting. Okay, even though not I didn't see much after that, but this idea was interesting. That's why I thought people are working, and I'm helping right now. In fact, NIT Raurkela people to design some things which will have security and energy harvesting together, and those I may discuss a little bit, and this is an idea. So we are discussing energy solutions, and this is one work we did where we modeled how we can have a combination of different cells, so then capacitors and so on together, so that energy storage is better. That is what we can do. And this work I was helping here, this one, I think NIT, some I forgot, maybe. Anyway, some NIT I was helping, where the idea is how we can have supercapacitor based battery, for the cars, and then study their power delivery profile, how they stand with respect to the battery. Supercapacitor versus battery, that's the idea. So if you see here, all the energy management solutions that we saw, okay, typically they do not target cyber physical system. That's coming from mostly, let's say, people working on like power kind of background, power electronics kind of background, and they don't worry about cybersecurity at all. They design something, but at the end, when we are assembling a system, making a smart city, making a smart village, we buy these as component. We then have to use those, and these do not have any security aspects. Okay, these are just energy aspect they are discussed. So big challenge. That's why these energy solutions have to combine with these what we saw, these security solutions. How to use all those together. Okay, that's the big challenge actually. So that things are together. Now, when we go to AI solutions, a lot of AI solutions, whether this is a smart sensor, okay, that this is some sensors developed by, I think this is Carnegie Mellon people developed this sensor, which is all purpose, even though I'm not fully convinced that you can have universal sensor. Sensors are very unique. Anyway, and then these are market flooded, that is end device, which are personal assistant devices and so on, we can say, whether it is Apple Siri or Alexa. Okay, and these are running a lot of models, okay, that we are familiar and we are using. So those have a different application. Now talking to only AI. So these are driven by AI. And this is a smart healthcare solution. For example, a Fitbit-like device. Again, AI. Okay, we are not worrying about security here. And we did one work here called Smart Work to monitor the activities, are better accuracy than the what you can say Fitbit. Then diet monitoring automation is one example here, that is like we developed, where we can automate meaning we want make the quantification of calorie automated. That means what we ate, okay, that is the system keep tracks of, and then tells, okay, how much was our calorie consumption, and then accordingly can advise something. Anyway, and another work we did here is the stress management. Again, AI is the underneath thing, and this is one student. She just graduated maybe last month, last month, and she's joining as faculty in North Carolina from August. So her work was on this, that is stress monitoring and control. So we developed some AI devices, AI-based devices that monitor the stress and then advises how to control. And this is very important that when she was on the market for job, like 10, 15 interviews she got, and I was really surprised that she got so many, even in a bad market right now. So the key idea is the people like the stress aspect, and here we developed AI models, so that is doing stress monitoring, not just from body temperature, physical activity, sweat, then food intake. Somebody is eating too much because somebody is combined, and we have a
বেশ পুরা লাগিয়েছি পুরা
we have a very good solution in stress monitor and control. And this is one we did. We called it Hello.
Hello.
Okay, so we called it Smart Pillow, where we embedded some electronics to the pillow, and that pillow was keeping track of the sleep habits to essentially do two things. One is because of somebody's physical activities at the daytime, how somebody's sleeping pattern, and because somebody's sleeping pattern, what will be somebody's next day behavior, like that. That is the what you can say idea behind this, and this is again AI driven, and we have expanded this work to a big idea that we called as Sai Pillow. We called it Smart Yoga Pillow. That's the name, and this is keeping track of the sleeping habit. It's basically there in a pillow and the sensors, and this is a very good work that we did. We are not just demonstrated that is how simple sensors can help us to keep track of our sleep and then advise eventually on the next day, like physical health and so on. But one big deal here also we demonstrated in this system, that is how we can have also security mechanism and so on, rather privacy mechanism, so on, so the data is stored in private space. But anyhow, before we go to the details of the security and so on, okay, we have another device here called iLog. That iLog is a fully automated. I'm very happy to report this work, where it's a fully automated diet management system that is keeping track of the diet, what you ate basically, and automated. That means, for example, I still I use a lot of these smart healthcare devices, but I still I'm not convinced that what we eat throughout the day can be fully automated. But we have reasonably succeeded, okay, in making this automatic. But I have still problem. I say, oh, still we cannot enter water, water intake every day. We are still doing manually. So I have to do that is also automated is a challenge, and we are thinking of. But this solution iLog really works and has automated fully all the diet intake. And iMirror is one work we did where we are again analyzing the stress, taking a picture, let's say somebody's picture. Everybody has smartphone and so on. One can just take a picture of himself or herself and then knows what is the stress level. So this work we call IFLs, which appeared in Smart City Conference paper last year, where we are advising the user of this device the long-term and short-term advice on stress management. Okay, one we analyze the stress level from various activities and so on, and advises what somebody should do. For example, to do the breathing exercise, take shower, and so on. And like Good Eye is another work we did around 2 years ago. This work is doing elderly fall prediction and detection. That means somebody elderly person wearing let's say a camera, and then from the camera data, and also we can have a simple accelerometer kind of thing, and so on we can keep. And sorry, yeah, because disturbance was coming, I muted myself. Okay, anyway, so what I was saying, this work on smart healthcare that involves each signal, two of my students worked on this, two PhDs, and one has joined IBM, another has joined New Mexico as faculty. So what we did is very interesting. We came up with a complete framework that will automatically detect seizure, rather detect very fast. Early detect is the right word, medical point of view. Early detect the seizure, and then suggest the drug delivery injection. Okay, what amount of drugs should be released as a result of the severity of seizure and so on. So we compared cloud computing paradigm in this context, IoT computing paradigm with edge and so on. Okay, meaning IoT cloud computing paradigm, IoT edge computing paradigm. We compared, and we could detect seizure in the range of 1 second eventually. So that's again AI-driven work, and this is we're very proud that we developed what we called Cricking based easy early detection method that captures the easy data, so the correlation in easy data, and very fast, within less than a second, monitors detects the seizure. So this was like a very good combination of different wavelet transformation, then the Cricking classifier, and so on. So if you see all the AI techniques which are we discussed here, they differ various applications. As mostly I discussed healthcare because that is where right now my current focus. Most of my students have been working for last 5 years or so, and as I said, around 4-5 PhDs I produced in this area. And if you see all these, do not worry about that much energy issue. Do not worry that much about cyber security issue. So then I've been thinking last 2 years or so, how do I combine all these to develop something that is what you can say, taking care of all the ideas. Okay, so like then if I analyze, okay, that is drawbacks of existing security solutions are quite a bit. Okay, that is, for example, we have a lot of security so people are working around the planet, and then when we see what are the drawbacks, I started thinking, okay, can we first think, okay, whether existing IT solutions that we have, we can deploy for IoT. Okay, that is the first question I asked, and you will see you will not find much information like this, IT versus IoT. So IT infrastructure is having, we have been talking about IT for last maybe 30 years or 20-30 years easy, and they have different IT in the IT sector. Different servers are there, different IT devices are there. Okay, but IoT, when we're talking about, this is way different domain, in the sense we are not talking about something other than computer, okay, which is connected to the internet itself. So internet is there, no doubt, but different devices. So as a result, when if we are in the IT, we are talking about millions of IT devices, computers, and so on. And in the IoT, we have billions of IoT devices. That is what we are talking about. And in the what is that? In the what you can say. In the healthcare, if you specifically see this one example where we have shown pacemaker and insulin pump, all these things, and all these together are called like implantable and wearable medical device, okay, IWMDs, okay, and they have serious challenges, serious energy constraint, okay, even though we desire longer battery life and safer and so on. So if I want to give the exact context, if you see implantable like pacemaker has 10 years of battery life, and a neurotransmitter like that is 8 years battery, let's say decade. Okay, and if we they do not have what a pacemaker does, it generates essentially some electric pulse. Okay, that electric pulse is given to the heart, and it doesn't have a lot of compression power. Okay, and similarly, neurotransmitter doesn't have much compression power. But when we want to what you can say, make them secure, okay, how do you do? That's the challenge. If they do not have battery, they do not have compression power, and all these have to be secure. Okay, that is why it's challenging. And similarly, to secure transportation devices are also not that easy, because the more features, whether security feature and other things you add, they will take what you can say their own battery, and they will have their own latency problems. Similarly, we want to secure, let us say a drone. It has its own set of challenges. Okay, so securing drone, because drones do not have that much luxury to on the battery life, because all these flying range is limited by the battery life. Okay, so aerodynamics, all these things are affected if we do what you can say if you add security features. Similarly, smart grid devices, whatever, also if you want to add security, a lot of issues are there. And now I wanted to discuss a little bit about blockchain security problem, energy problem, and so on. Blockchains are as if like it's a solution for everything, right? Since the Bitcoin came, blockchain came to limelight, and people then adopted, okay, for healthcare, agriculture, energy, everywhere they're thinking, right? Blockchain, in fact, all the industries, if you see, take IBM and so on, Okay, somewhere or other, people have some blockchain-built solutions. Okay, because they think there's a lot of potential, right? Anyway, so blockchain is not straightforward. Okay, and in fact, we have done a lot of work on blockchain, a lot of healthcare applications we have developed. Now I'm thinking of, rather I started to use in smart agriculture, all these things. And what is that? This blockchain in general has a lot of what you can say problems. They are not straightforward. And high energy consumption, lack of privacy, attack, and so on are problems, and one needs to deal with those. And when I compare like a credit card with a Bitcoin transaction, okay, we swipe a card, okay, and we pay by a Bitcoin. The energy requirements are way magnitude different. Okay, a transaction in Bitcoin consumes 80,000 times more power than credit card. So whether it's worth it, so that is the question. Similarly, mining a Bitcoin uses 2 years of US household. Let's say 1 year, let us say electricity bill around $1,200. Let's say 2 years is more than $2,000. That kind of energy we need. And blockchain, we saw energy requirement. These are different problem. Energy requirement, then security problems themselves are there. In fact, in this article we wrote in March 21, I suggest you to read the details. A lot of different security threats we discussed. And privacy also, people may think when you are using blockchain you are anonymous. Answer is no, you are not absolutely anonymous. So it can be traced to blockchain, and other things can be traced. So it has privacy issues as well. And specifically smart contract, which is an example of public domain blockchain, okay, that is having its own set of issues actually in terms of security vulnerability. When we compare attacks happening, cybersecurity attacks, software versus hardware, both these two forms one can happen. Software is attacking communication channel, then selected software-based attacks. I have given some example. Hardware-based similarly can be there, and these hardware problems, as I mentioned, particular Trojan are much more problematic. Okay, you cannot easily trust them. Okay, so those are kind of built in the system. Then they can really cause problem, which IT-based solutions like this will not easily capture. And so the way attacks can happen software versus hardware, solutions can also happen software versus hardware. So softwares create latency problems. They create higher operational cost because you are updating software. You have IT personnel who is taking care of the maintenance of those. Okay, whereas hardware can be relatively straightforward, but can increase the cost of the hardware itself, of course. And then these things attack, meaning when you have hardware solution, one good thing I like, that's why hardware-based solutions more, that is these are easily integrated in the electronics. But this problem, which is going to come, okay, in fact, people have demonstrated how they can break 2000 bit kind of encryption in few hours using quantum. So quantum is going to create serious problems. So as if you see in general, okay, these cybersecurity solutions as a result not necessarily targeted to specific energy requirement solutions or AI problems. So that means how do you do cybersecurity solution that takes care of energy are again unrelated problems. So with all these things needs to be combined. As a result, a new paradigm is coming, and I coined this hardware assisted security 2009. In fact, I wrote a first paper, hardware assisted copyright protection, and then we have been doing something or other in the multimedia protection, then security and so on. Then when I saw this thinking, I mean, so I was doing this thinking, that is hardware-based solution versus software-based solution. Then at the end, we thought, okay, hardware-assisted security, that is where hardware is a part of it, and then software can be there, or may not be there actually. So in general, that's why we coined the term hardware-assisted security. We have been working for last several years. But then I find that is secure by design. Some community came up with that idea, which is essentially same thing, but it evolves from privacy by design. The privacy by design came from somebody, I think I forgot her name. She's from Canada, one person from Canada. She developed privacy by design, and then that Europeans General Data Protection GPDR adopted that privacy by design, and then from that privacy by design philosophy, security by design or secure by design came, and which is essentially what I have been advocating in what I call hardware associated security. That means hardware protect itself, okay, and protect the data, protect the system. So this has paradigm or security by design paradigm can then take care of these what you can say different axes, okay, that is energy consumption, security and privacy, intelligence, then performance, and so on. All these things you can take care. And so this is what I was saying, that is privacy by design, okay, it came from European law, integrated European law, and then people parallelly, the way privacy by design, security or secure by design idea came, which is essentially what I've been calling as hardware associated security. So the idea is how do you embed security and privacy as a design flow problem instead of retrofitting. That's the simple idea. Okay, and I did a special issue in March 2020. I do recommend all of you to read March 2020 special issue. A lot of interesting articles are there. And 7 principles are involved in doing security by design or privacy by design. And this is original article is there, in the link is there, who developed privacy by design in Canada. I forgot her name. Anyway, you can go through that. Now, if you see all these discussions we had, cybersecurity, energy, and intelligence are the 3 things that we are seeing, and at the end, they are together problems as a problem. And in IoT system, which is sensor-driven, data-driven, and so on. Okay, and all these that is why I have to be combinedly taken into account to optimize so that we have very good electronics. Now, what is hardware associated security, if we want to say, okay, that is hardware security provided by hardware for information being processed, hardware itself, overall system. That's a HAS or SBD we can call. Okay, and this is not easy problem, very difficult problem. The reason being the hardware are variety in nature. Okay, it is digital hardware to memory. Okay, it's not exactly same, or infrared or like even in the RF or analog design hardware, all these are different. Okay, so very difficult problem, but that is what I advocate. And in fact, this I gave a talk 2007. This talk where I was mentioning about how we do SOC design modification so that we can have hardware associated security, and we can have different basically algorithms, different protocols, different architecture, and so on. And this idea I'd what you can say developed, and 2005 this work was presented, what is called secure digital camera, and this then I have revisited, and a lot of other publications I have based on this. The idea is essentially driven by same, that is security by design. How I demonstrated in the context of a camera, okay, that is secure digital camera, where secure digital this has features which is like a POF, physical uncontrollable function, and other things, and then this whole system is taking care of itself in terms of the security of system, in terms of the data it is processing. Anyway, and we have designed different variants of this secure digital camera. This is one variant where we dealt with different graphics. We call it better portable graphics. Okay, and then other things we have done. And this work here, PMSEC, this is very widely what you can say acclaimed work that is how we integrated in the smart healthcare framework physical uncontrollable function and demonstrated with the protocols what are the doctor's end and the user end and so on protocols we developed, and as a result we have a foolproof solution. Okay, and this was some security which is consuming around 200 microwatt of power for authentication and so on, but I really want to see the security happening with even 2 microwatt or 1 microwatt or even close to 0. Okay, but this is a good beginning, I can say. And we have also redesigned blockchain. Okay, and we analyze the blockchain power consumption what is going on. Transaction block validation consumes a lot of power. This, and we redesigned blockchain so that the blockchain, this is the first work we did, which is in fact, if you see, first IoT driven rather IoT friendly blockchain, which we did in 2019, January 2019. And before that, blockchain mostly targeted our cloud computing, IoT cloud computing paradigm. We brought it to IoT edge computing paradigm. And what is that? To make blockchain IoT friendly, okay, we have what you can say proof of authentication paper we published, which is taking care of those blockchain which is IoT friendly, and we developed new block structure, we developed new consensus algorithm so that blockchain runs on IoT, and this is an idea of how consensus we develop. And if you compare a original blockchain, like if you see few years ago, all the graphics cards were gone because everybody was doing Bitcoin mining. Now what we are seeing, hard drives are gone. Hard drives are extremely expensive. Rather, price have become double in last 1 year or so, because new type of digital, some cryptocurrency is using storage as its consensus algorithm. Okay, proof of work here was using essentially the computation capability as the consensus. They are right now storage capability is constant, so that's why hard drive prices are bad. It's like double in last year or so because of the result of that. So that's why power consumption or storage, those are important things. And in fact, that's why one of my student is working on this aspect, how we want to redesign the blockchain that will have scalability, that is going to take less space and can store a lot of data. Okay, scalable problem I call it. This is energy requirement problem that we had reasonably solved. That means a blockchain running in a Raspberry Pi kind of a 5-watt kind of power. So this is a significant work we did, which is 200x power reduction. Okay, this is another work we did, what we call POP chain, where we integrated hardware in the blockchain itself. That means you have the blockchain not just running in a client node or so on. Also inside there, POP is integrated, and as a result is what you can say. This is not more secure and energy efficient. Okay, that's what we're running, and this POP chain, that's why again we claim this is the first hardware integrated blockchain that is presented in any literature in the world, and hopefully we'll have much more in this area as well. And what we did here is we integrated POP in different client nodes, and those POPs are handshaking, doing the security, and blockchain is basically taking care of other things. And in fact, this work has a lot more potential as my students are working on it too. And I want to make it not just secure, I want to make it scalable. So that means we have to come up with off-chain storage capability. So that means blockchain is essentially managing the access control, and off-chain storage is there, and then security is provided by POP. That's the big idea, and hopefully we'll eventually develop that. And again, to integrate POP, which is physical on-clone function, we had to develop a new consent algorithm. We call it POP, POP-enabled authentication, and this is doing authentication through the. So again, block structure was changed, new protocols for consensus, and all this. This is an excellent blockchain, which is consuming way less power. That is 1,000x faster than proof of work, and consuming 3-watt to 5-watt kind of power running on the Raspberry Pi kind of work environment, computational environment. So this is an idea that I was mentioning. One student is working. Ahmed is working on this. I just started. Where we want to make the data structure of blockchain more compact, and as a result, the storage requirement will be less. And we are calling multi-cell technology, 2 different blockchain for device, for data, and so on. We'll see as we develop more. This has a lot of promise. And in fact, eventually, who knows, we can make it a minerless blockchain, and so on and so on. So this is ongoing research going on. And this so far, consumption time is less than 1 second, power consumption is less, and this is 4,000 faster than proof of work. That's what we claim. And again, different blockchain structure was changed, and different data structure, and so on. So hardware being made secure by hardware. So ideas like interesting thinking that we have been doing, and POF is our predominant solution. And related things we can say TPMs are also reasonable thinking in that direction, or hardware security model HSM, and so on. But HSM is server class. This is actually kind of a little bit Trojan, whatever, in mobile computing platforms. Then TPM is there in many places. But POF has its own. People have been exploring last several years. Okay, but it came from MIT, the new original idea POF, and a lot of people have since then engaged. Okay, and let's see how far it goes. And one PhD student of mine worked, and another PhD student right now has started working. And but a lot of people around the planet are working. We have developed some unique solutions that is to integrate with blockchain, and that is to take it to smart healthcare devices. Those are a unique solution. As a result, we have multiple federal US federal grants on this area, that is use of POF, use of blockchain in the smart healthcare. And more details you can see in my website if you are interested. Okay, so the idea of POF is essentially to have the hardware that is unique challenge response pair, so that unique challenge response pair we can use for security purposes. And that is what is the research in this. Variety of POFs, again, as I said, tons of research is going on. And this is the in my guest editorial in July 21, I have discussed this variety of POFs. We also wrote an article maybe around, I wrote that, no, with my student and collaborator, we wrote around 5-10 years ago on everything you wanted to know about POF. You can read that article that has a lot of discussion of this, or this is a very good guest editorial that we wrote on the POF. And we have designed variety of POF. This is ring oscillator POF and so on. This idea I really want to bring. This is very interesting. I helped NIT Rourkela people to do this. This work, it was very interesting, and reviews are excellent. Of course, finally we got this paper April 21. It was published. The idea here is how to have security and energy harvesting together, and I named it nicely called eternal thing, in the sense it is harvesting energy. It's not consuming energy from the grid, and it has a supercapacitor and so on as temporary storage, and then it is providing security because we have built POF from the oscillator and so on available as a part of its transceiver and so on. This is a very neat idea. And then another idea, this is again is very important work, you can say, in the security by design paradigm. That is eternal thing 2.0. This where we are hardware Trojan also we are protecting, in addition to making it security friendly. So you can read much more details of that in another paper. So then important is what did that say, power resilience, how we can make hardware whose power trace will not lead to security leakage. That's the idea. So differential power resilience, that is the side channel attack and other things are there, which essentially can be exploited to to break the encryption. So this is one work that is definitely has a lot of potential. We haven't done much. We have done 1 or 2 papers I did long time ago. 2013, but this has a lot of importance. But this I'm more interested what is called in the whole IoT paradigm. Okay, how to decide where to compute, what to use for computation. That I'm very much interested. Why? The reason being, these paradigms will determine, okay, whether IoT is being used for the smart cities or IoT being used for the smart villages. And as a result, that's why when we're doing healthcare or transportation and so on, we are evaluating those two paradigms. This big picture gives that. So that is IoT, whether it is end device, edge device, or cloud. And here in these, we are doing what we use the term tiny ML. Okay, that is how to have light duty machine learning model, light duty security that will run in the end device. For example, in my Fitbit wearable, we have to have some machine learning model. In my let's say, for example, my Raspberry Pi small hardware connected to my home what you can say, lock, how to have a small security mechanism there, like that. Those kind of thinking. TinyML, lightweight security. Okay, and this is we can have a medium level. Okay, and in the cloud we can have heavy duty. So that is why what I'm saying, probably this right side is more suitable for smart city, but left side is more suitable for smart villages. Anyway, and this is an article we wrote, and I definitely recommend all of to read this March 21, where we are saying don't use blockchain everywhere. Where to use blockchain, one has to be very particular. Okay, that as answer in one single way. Untrusted nodes are the only reason why you should use blockchain. If trusted node, do not use blockchain. Waste of energy. So we have to do something better. So that is why we are developing in general what we this term existed, digital lasers, okay, or distributed lasers. So we are basically trying to do what we call next generation blockchain, multi-chain, borrowing some previous thoughts of distributed laser and so on, and we'll see how that goes. So that is the whole idea of that paper. And this in this work called Cypilo, we demonstrate not just we are talking about healthcare device. Let's say in one family there are 5 different members, or in a city millions of people buy the pillow, but they want to have their data privacy assured and so on, and how we can have a blockchain. Let us say I'm the pillows what you can say manufacturer, I'm selling 10 million pillows, and how what you can say that data that is generated can be there in a privacy secure fashion that we demonstrated in this work. And data is very important, quality data. Okay, how to store the data, how to model the data, what is the cost of data. All these are important problems actually in the data. And this is interesting slide. What that tells, data quality, the weight is important, which I call like good data and fake data. Similar problems, good hardware versus fake hardware can be there, and these are both are dangerous, both are bad. Okay, for the cyber physical system. For example, bad data can give a bad model. The way I was giving an example, suppose stop sign is mentioned somewhere predicted as slow, drive slow, slow sign. Similarly, if you have a bad, can you anybody imagine, comprehend the problem? You have a pacemaker, which is a fake pacemaker, fake hardware as pacemaker, how bad it is. Okay, so those are serious problems, and those are really, those are not, I'm not talking just like that. Okay, now if you see last few years, okay, market is flooded with fake hardware. Okay, not just like you can have a camera. When I buy camera, I immediately go and register with the manufacturer, because I want to make sure my camera serial number is clearly associated with the manufacturer serial number. So that's I got a good camera, not a fake camera. When you buy from eBay or Alibaba or somewhere, even Amazon, you never know. So anyway, so similar fake hardware can be a really serious problem. And I always tell, fake battery, do not go for it. The reason being, fake battery may catch fire. You have a camera, you have a smartphone, and you have bad battery, okay, it can catch fire. So anyway, so fake data, fake hardware, and all these are, and this bottom is an example. You have a high-end car, let us say BMW, okay, and you are buying electronics, or somebody, for example, a mechanic put a bad electronics which is cheap, okay, and then that electronics ECU, electronic control unit, is for your headlight or for your brake, and you may have a problem. So anyway, so those are serious practical problems, and I have parallelly worked always on that, how to have data, as well as this was during a master's I was doing 20 years ago, and rather more than 20 years ago, and then this I've been doing as at the hardware level, okay, maybe 10 years ago. So this interesting article you wrote on the watermarking, that is how from the data till hardware till the, everything is what you can say uniquely authenticated, so that you don't have fake data or you don't have fake hardware. So this, I encourage all of you to read that. And this I've been doing, of course, as I said, right from master's days. So that is 98, early 2000, rather before 2000. So anyway, this chip we developed in 2005. This was published, which is first ever watermarking chip that is doing basically taking care of data quality issue. And this is also data quality is another chip we developed where we have visual data integrity aspect we handled, and this is a demonstration chip that has what you can say low power chip to do the data quality. So all these things are there. We developed, and this for video. We developed how to ensure video quality, video data is original video. And this some people again some researchers borrowed some of my idea, inspired by the idea. This they developed what they call trust cam. This was done in Austria, which they acknowledge, of course, the watermarking work I did, and this is the idea they developed. This is some people think in Calgary in Canada. They borrowed my idea on the watermarking, and then they integrated that at the sensor domain. Okay, that is in the pixel sensors, active pixel sensors. They integrated that idea. Important point, data quality in the AI, as you can see, how to have like a curation of the data, or then all these things in data that big data community may need to work on with. That is so that data throughout its source of generation to storage and so on uses is good quality data. Anyway, and so towards that direction, we have been proposing what is called is data centers. That means data centers are small and they are secure through some certain mechanism. We proved in this paper that is 2 years ago. We presented this of as data center. And then all these what you can say is data center and so on can go well with what we call as TinyML, which small servers are training, and or at a time some data servers are working together, and at the end predicting with the TinyML or lightweight MLs. This paper we presented just May, like this last month. This is interesting. I bring to your attention what we propose the new idea of what we call collaborative edge computing, which is I considered as a cost-effective, sustainable computing for villages. So that means each village can have small computation, and then when they want to, they need let's say 10 villages, they need a lot of computation resource. That time they can work with each other to collaborate, and can have like distributed computation capability. And when they don't want to collaborate, very minimal requirement is there, then they just use one of the data centers. So like that idea. So I hope all of you liked a lot of material, and do feel free to ask me questions right now. I have some time because this was 2-hour session, and then over email also you can later on ask me, and so on. So we saw a lot of different cyber physical systems, software, hardware-based attacks, then software hardware-based solutions, and what is the big idea, big takeaway is what is called hardware-assisted security, where hardware integrated to secure the hardware itself, or to secure the data being processed, and secure the overall system. That's the idea. And a similar idea of this is what is called security by design, RSBD, where retrofitting is basically discouraged. And that's what it has philosophy. The future direction, a lot more research obviously needed. This is again at least I have 2 different projects up to 2024 to do much more in this, and stay tuned to my website, and then how they can be applied to sustainable smart city and smart villages, because are important research direction. Sustainable, where I'm saying they are energy efficient, they are secure. Okay, and obviously we are doing AI built in those. So that's the big idea. So anyway, so thank you all of you, and please feel free to ask me any questions if you have right now, or we can also take questions, as I said, by email and so on.
Thank you so much, sir, for making this topic this much understandable for our participants. If anyone have any queries, then please post it on our chat box so that sir can clarify it.
Any questions? And these slides are there in our website, as I said, and also, as I said, if further questions, right now you can ask in the text chat window, or you can ask me later on by email and so on. What is that? Okay, okay, thank you, Ranjit. Okay, then from Mohammed Abdullah, I want to do research in the field of cybersecurity. So, which area will be best to explore? Okay, so cybersecurity. Okay, as I was mentioning, I'm predominantly now focused on healthcare and followed by agriculture. Okay, and I definitely encourage to work on any of those: agriculture, healthcare, even energy sector. Okay, all these have different challenges, and I was mentioning how to, for example, make a autonomous car secure. Okay, all these are different domains, and they have unique challenges. I recommend to work in any of those depending on what you like most. Always research, I always tell, what is important is you need to really like it. Okay, that is something you are passionate, and do it. So that is like either of the, I mean, any one of them is a very good area to work on. Okay, any other questions here? Okay, so Barrett, if somebody asked the TPM being used in latest Windows 11, that's a very interesting question. Okay, I don't know. Yes, TPM is integrated. I mean, no, rather, TPM is a requirement to have Windows 11. Okay, but I don't know. A lot of people are saying Microsoft may back out from this because, or they may not back out because they want to force you to use new hardware. So anyway, so that is the future. That is Windows 11 coming. It has a requirement to have TPM that I am reading as well. So I'm interested in health. Somebody has asked, I'm interested in healthcare IoT. Explain path to explore. So that's a very interesting question, and the answer I always give to that, always as I mentioned, what you like, you do that. Okay, let's say in healthcare you want to work on fasting is the application domain. You want to do diet management, you want to do stress management, you want to do quality of health, basically heart disease monitoring, or you want to do seizure, that is brain. Okay, all these first is important to what you want to work on. That is how the healthcare first requirement. And once that application domain, then you think what you want to do, whether you want to develop sensors for it, or you want to develop security solutions for it, like that. Okay. Any other question? So please tell something about security issue related to smart agriculture. Very interesting question. Somebody, Rosa Lynn Malik. Okay. So yeah. So smart agriculture. For example, when you are connecting everything, every agriculture activities in that domain. For example, water control. For example, fertilizer control. All these things. And you are automating. So anything you are making automatic, you are connected, and then as a result, or even UAVs going to our going to the fields or agrobots. Okay, the agrobots which are doing cultivation themselves, or all these things. So they can be hijacked, they can be hacked. For example, one changes the what you can say fertilizer sequence, it makes different, or something with that sort, or even the water level different. You wanted water to be in a specific schedule, somebody hacks it and puts another schedule. Those are the kind of problems. So in general, what I can say is in anything connected that has a cybersecurity challenge, and depending the application domain, those challenges differ in terms of what devices, what connectivity, and so on. Okay, any other questions? Otherwise, how to distinguish between defective and attack chip? It's a very interesting question. Okay, so it's I don't see the meaning how to defective. That means it's very interesting. So for example, maybe we will say first with the functional correctness point of view, a chip is working or not. Okay, then after that, the second level of thinking is whether some chip is attacked or not. So, but as I was mentioning, hardware, that is why attacks and hardware cybersecurity problems are much more difficult to catch. Okay, and it's like it's not as simple or easy fix. Okay, when you have security in the CPS domain or hardware specifically. Okay, it's a very interesting question, Devasis. Okay, so if no other questions, so thank you all. Or if you have questions, please feel free to email me. Okay, and these slides will be there in my in my website, and please feel free to go through. And if you have any questions, please email me.
Thank you so much, sir. This was
Yeah,
a
thank you.
magnificent session on cybersecurity and trade-offs in IoT. I'd like to thank our esteemed speaker, Professor Mohanty, for giving us a considerable source of knowledge on this content. We really appreciate your efforts and valuable time, sir. Thank you so much.
Okay, thank you.
Thank you, sir. A lot.
Sure, thank you. Please be in touch. Thanks.
Just a minute, sir. Sir, are you present? Hello, am I audible?
Orbita, can we take one video of one photograph from all participants with our
Okay, sir. I'll request all the participants to please switch on their videos. Please stay muted, but just switch on their videos for a picture purpose. Yes, I can see participants. Please stay muted, but switch on their video so that we can take a picture and also the visual attendance. I request all the participants to please switch on their videos. Yes. The rest participants, can you all please switch on your videos? Okay, who are able to switch on their videos, please kindly do that.
Hello, sir. Somewhere my camera is facing problem, so I'm unable to start my camera. Please consider
Okay,
my
it's
excuse.
okay, but who are able, they can please switch on their videos. It will be completely fine. It's just for a record purpose. Sheet is already provided in the chat box. All can fill it from there. It's just for a record purpose, so I'd request all to switch on their videos, please. Yeah, it's completely fine. If you can't switch on your video, it's completely fine because the attendance link is already given in the chat box and the attendance will be considered from there only. It's just for a record purpose. So if anybody is able, please switch on your videos. Okay, I think this is enough. Thank you. Thank you all to switching on. Thank you for the cooperation. Now you can switch off your videos. Thank you all. Okay, so yes, another thing, please excuse us for the disturbances created today. All of that will be taken care of by the organizers from now on. Yes. Okay.
Yeah, excuse me, ma'am. Where are you sharing the attendance link? I have not filled yet.
The attendance link has been sent in the chat box, ma'am. Please fill it before we start the next session. Today we are giving the attendance link for each session separately, so don't forget to do that. It's mandatory for all the participants.
I haven't filled it yesterday also.
Okay, sir. Ma'am, I'll have to talk to our coordinator for that purpose because yesterday we shared only one link for the whole day.
But I didn't fill that.
Can you please resend the attendance link?
Okay. That I can do. Today's attendance link, I'll share that in the chat box. Yes,
Yeah,
the
you will
attendance link has
send
been
me.
sent already. Please do that before we go to the next session. It is mandatory.
Have you shared it right now?
Yes. The link has been sent. Please check the chat box for the attendance link. It is really a mandatory field, so I'll request all the participants to stay alert because we are sending the attendance links while the sessions are going on. So please stay alert and check the chat box whether the link is shared or not, or you can freely ask us if you are not getting the link, we can reshare it, but the link will be shared only during the session and not after that. So please stay alert for that.